Here we're going to be looking at some graphs of equations. Let's start with an example of an equation that has two variables, x and y, in it. So whether this equation is true or not depends on what numbers you put in for x and y. So a solution to an equation like this would be not just a number, but a pair of numbers. The first number is x, and the second number is y. So, for example, 2, 0 might be a solution. Let's check. If we put 2 in for x and 0 in for y, is the equation true? Is 2 times 2 minus 0 squared equal to 4? Well, 2 times 2 is 4. 0 squared is 0. 4 minus 0 is 4. So, yes, that is a solution. What about 0, negative 2? Is that a solution? Well, this one's a little controversial. When I do this in class, some students say yes, some students say no. What do you think? Remember, you can pause the video if you want a little extra time to think about it. But we need to know if we plug in 0 for x and negative 2 for y, are the two sides equal? Now remember, we have to follow the rules about the order of operations. So exponents come first. We got to take care of the y squared before we do the subtraction. And y squared means that whatever number we put in place of y gets multiplied by itself. That number gets squared. And when you square an even number, or when you square a negative number, the result comes out positive. Negative 2 times itself is positive 4. Meanwhile, over here, 2 times 0 would be 0, and 0 minus positive 4 would be equal to negative 4. So, no, that's not a solution because this equation is not true. We have negative 4 on one side, and that's not equal to the positive 4 on the other side. What about 4, negative 2? Is that a solution? Well, 2 times 4 is 8, minus negative 2 squared is 4. 8 minus 4 is equal to 4, so yes. What about 6.53? That is where x is 6.5 or 13 over 2, and y is 3. Well, if we put those numbers in, 2 times 13 over 2 would just be 13. 3 squared would be 9, and 13 minus 9 is equal to 4. So yes. Now, what do these solutions have in common besides they all work in that equation? Well, they all correspond to points along this curve that we're looking at here. It's a sideways opening parabola, but this would be the graph of the equation 2x minus y squared equals 4. So the graph of an equation is made up of all the points whose coordinates are solutions to that equation. So for every point on this parabola, every point on this curve, if we plug in the x and y coordinates of that point, 2 times x minus y squared will equal 4. It works for 2, 0. It works for 4, negative 2. It works for 6.53. It does not work for 0, negative 2, which we said was not a solution to that equation. So it's kind of mind-blowing when you think of it that if you write down an equation with an x and a y, that all the pairs of numbers that satisfy that equation fall into a particular pattern. They all line up in a particular line or curve that gives you a picture of what's going on with that equation. So what we mean by graphing an equation is finding that pattern, that curve or line or whatever that represents all the solutions to that equation. So how do we do that? How do we draw the graph of an equation? Well, we can do it by hand, or we can get some machine help. We can have a graphing calculator or computer or something like that do it for us. First, let's do one by hand, just ourselves. If all you have is pencil and paper to draw the graph of an equation, now sometimes you recognize what kind of an equation it is, and that gives you a hint as to what the graph is going to look like, whether it's going to be a straight line or a parabola or a circle or something else. We will be talking more about that later on in this section and then later on in other sections later in the course. But for now, suppose we know nothing about what to expect, just that there's some sort of pattern, some sort of line or curve or something that all the points that satisfy this equation fall into. How can we figure out what that looks like? Well, we can start doing some calculations, finding some solutions, and plotting some points. So the way this is set up with y equal to x squared plus 2x minus 8, we can start by plugging in some numbers for x, doing the calculations, and seeing what we get for y to go with it. So if you plug in 1 for x, the y that goes with that would be 1 squared plus 2 times 1 minus 8, which is negative 5. And so one of the points on the graph is the point where x is 1 and y is negative 5. If we plug in 2 for x, 2 squared plus 2 times 2 minus 8 comes out to be 0. So if x is 2, y has to equal 0, and we get the point 2, 0. Plug in 3 for x, 3 squared plus 2 times 3 minus 8, that would be 9 plus 6 minus 8, that comes out to be 7. So one of the points on the graph is 3, 7. If we put in 4 for x, 4 squared plus 2 times 4 minus 8, well, that's 16 plus 8 minus 8, that's 16. So that's going to be way up here somewhere. If x is 4, y is way up above the part of the graph we got showing. Now, don't limit yourself to just positive numbers. Remember, x can be anything. It could be positive, it could be negative, it could be 0. In fact, let's try 0. If we put in 0 for x, 0 squared plus 2 times 0 minus 8 would just be negative 8. So the point 0, negative 8 is on the graph. Let's try some negative numbers so that we get the full picture. If I put in negative 1 for x, negative 1 squared would be positive 1. 2 times negative 1 would be negative 2. And then positive 1 plus negative 2 minus 8 is negative 9. So there's our point negative 1, negative 9. If you plug in negative 2, you get negative 8. Plug in negative 3, you get negative 5. Plug in negative 4, you get 0. And now I'm starting to see a pattern. If we connect the dots, draw a curve that goes through all of these points, can you see what that would look like? It would look like this parabola. So to graph an equation where you don't know ahead of time what the graph is going to look like whether it's going to be a line or a parabola or what, find as many pairs of numbers that satisfy the equation by maybe plugging in numbers for one of the variables and calculating to get the other one. Find as many of those pairs of numbers as you need to see what the pattern is, and then draw the curve that goes through all of those points. Now let's talk about how you could get a graphing calculator to do that for you. So here's a TI graphing calculator. It's the most common brand. You might have a different one, and then you might have to figure out the exact details of how it works, but I'm going to push the y equals button. If there was something already there, I would want to clear it out. And now I'm going to type in what y is equal to. To get the x, I push this button here that has the x and some other symbols on it. So x, and then here's the button for squared, plus 2x minus 8. So there's my equation. Now to graph it, I'm just going to hit the graph button. And there it is. And it looks a lot like what we came up with ourselves. Now, if your graph doesn't look like this, it might be because you have the window set to a different scale, different coordinates. I've got it set so that the x's and the y's both run from -10 to 10. But if you don't, you can change that. You can press the window button and change the x min and x max to what you want the starting and ending x coordinates to be, and change the y min and y max. Or you could just hit zoom and select Z standard, which takes you back to that standard -10 to 10 in both directions. But sometimes you want it to zoom in more or less. You want different X and Y's showing, so you can change that with the window button. Another thing you can do while we've got this in here is we can get a list of points like this that our calculator generates. So above the graph button is the word table. And above the window button is the word table set. First, I'm going to set up my table by pressing second and then that button. And I'm going to give it a starting point. Let's have it start with x being -4. And then this tells it how much to go up by each time. So right now I'm telling it to start at -4 and go up by 1 each time. So now when I go to the table, press second and then the graph button that says table above it, it tells me that when x is -4, y is 0. When x is -3, y is -5. When x is -2, y is -8. And so on down to when x is 2, y is 0. I can use the down arrow button to keep going down and get what happens when x is 3 or 4 or 5. And another way we can set up this table is I can tell my calculator to ask me for values of that independent variable x. So if I select ask and then go back to table, now it's waiting for me to give it x's. So 1, enter, gives me the value for when x is 1. If I put in 2, I get that. If I put in 3, I get the 7 that goes with that. If I put in, say, 1.5, I get the y that goes with that, which is -2.75. Another tool you can use is the Desmos Graphing Calculator app. You can get it as an app for your phone or your tablet. It should be free. Or you can go to the online version. Just go in a web browser and go to desmos.com/calculator. And if you're on a computer, you can just type things in from the keyboard. But there's also a little keypad that you can use to type in an equation like the one we were working with. So I'm going to go ahead and put in y equals x, and I push this button to get it squared, plus 2x minus 8. And now I'll get this to go away. It was automatically graphing while I was putting that in. So what we end up with is the graph of that equation. Here, it looks like the x's go from -10 to 10, but the y's only go from like -6 up to 6. So we're not seeing the points way down there. But you can zoom in or zoom out using the plus and minus buttons over here. So there I zoomed out, and now we do see the bottom part of the parabola. And there's other things you can change. You can set the limits for the x and the y axis by hitting the little wrench button for the settings. So this is pretty easy to use and pretty versatile. You can just put in an equation and it'll show you the graph of that equation, and there are other things it can do. So it's a good idea to know how to come up with a graph for an equation, either just by yourself, by hand, doing the calculations and plotting the points yourself, or with a graphing utility, like a graphing calculator, graphing app, graphing program. And I've shown you a couple of the options. There are others. And then we'll come back in the next video and talk about some things we can look for when we're looking at those graphs. What does the graph tell us? What's the relationship between the graph and the equation? Things like that.